a joint work with Jung-Sun and Sang-Wei. Non-rigid structure for motion is based on its three trajectories. Two or point vector is combined with some assumption. Most of the existing NRCP methods provided efficient solutions to this holistic low-rank assumption. And simple enough. However, they fail to give formations or multiple objects in part-based reconstruction strategy. The input are reconstructed individually, and finally, this approach has many advantages. Moreover, if there are several objects in the scene, actually, there is a much more example. Waving arm is a deformation in the perspective. However, it is at the same time a rigid motion. Actually, can be seen as rigid motions of parts. The parts, then for the whole data. Applying such a strategy. How to divide the parts? Between part assignment and part reconstruction. Usually, these procedures are particularly loaded object to make the part as these procedures can be complicated methodology for this problem by pushing the concept of small overlapping parts randomly. Shows only a few dozens of parts, but I'm actually talking some statistical techniques to find the final answer. This bang-like approach has many pros. It's easier to pluralize. Moreover, this to either sparse landmarks or a dense surface without. So our method consists of parts, reconstructions, and finally strong reconstruction. For a sampling step, we define a good sampling point to have simple deformations and their trajectories to be this can be roughly interpreted as preferring Gaussian distribution, and this can be efficiently so now we have parts we want to reconstruct them. Strong reconstruction phase anyway, so short basis based reconstructor as the weak reconstructor. This is key, so we have to deal with it. It's generally composed of two parts, rotation calculation and shape. Usual rectification method, which requires one of the existing work provides a method to automatically choosing one that is good enough. Method, the best paper of CPR 2012. All information about K is needed. Shape from the two structures because apart and by applying ADA, we achieve. Since we are shooting orthographic camera, there are parts have been always an issue for part-based reconstruction. Drawing a pair of parts one by one, like this. Designer properly drew different parts. So there can be not so few amount of erroneous data at once for this problem. This basically minimizes reconstructions. Here we propose assume that most of the parts are accurate enough, then the correlation. If we substitute this into our problem decomposition, and this can be efficiently. Now we can derive consensus from these. For each trajectories, we apply median operation on it. The reason we use median is because we might have erroneous translation ambiguities between different groups, so we refer normalization problem. So as a summary, reflection correction and strong recursion is a simple problem with a practical solution. Benchmark data sets, including sparse and dense data, shows much better performance for dense, capoeira data sets for NRSFM. For very easy data sets, such as face or sharp, pretty simple deformations in the data. Because in the at once can be good. But overall, the proposed algorithm gives regular that the performance of the proposed method has very low standard robust under different random orders. We had a large amount of artificial rotations, and replaced them with much smaller ones, unlike the other methods. Some examples of weak reconstruction results. In a single frame, we can roughly say that the point groups that forming a line to have. Now I'll show you some videos. Left ones are the ground truth, and right do not have any smoothness assumption. Which has two objects in the scene. White lines on the left. Two objects. The proposed method does not need any separate scheme. Proposed method, but the errors in the 2D trajectories. This is even more challenging. See that the proposed algorithm handles it well. We'd like to thank Dr. Antonio Agudo for providing. It's quite accurate. The universal NRSF method that can be applied regardless of the type of input data. Efficiently bypassed by drawing consensus from randomly. It's a segmentation issue in multi-objective settings. One can be efficiently and globally solved by a rate. It's an interesting new direction of research for NRSFM. Finding better part sampling probability, or we are currently working on these issues right now and getting some promising results. So that's